Hello viewers and welcome to Math 24. This tutorial is on the quadratic proof. We start by writing the general form of the quadratic ax squared plus bx plus c equals 0. Then we carry the c term to the right hand side and it becomes negative c. The next thing we have to do is to divide all through the equation by a, and we will be left with x squared plus b over ax to be equal to minus c on a. What we are trying to do is to make the left hand side a perfect square. So what we are going to do is, for the term that contains x on the left hand side, we are going to take a half of it, square it, and add it to both sides of the equation. So we will take a half of it, square it, and add to both sides of the equation. That gives us b over 2a squared added to both sides. We now simplify the right hand side. Looking at the right hand side, the LCM will be 4a squared. From brackets we have 2 times 2 which is 4 and a times a which is a squared. Now 4a squared divided by a gives us 4a times minus c minus 4ac, and dividing with the other number we have plus b squared. On the left hand side we now have a perfect square. And this perfect square will be given by, you have the first term which is x and the last term which is b on 2a's. We put in brackets, that is x plus b on 2a's, all of that squared. When you expand, you actually have the left hand side as we have right now. So it's a perfect square now, and the right hand side is equal to b squared minus 4ac. I've just swapped the position of the numbers with respect to the signs. Now with the left hand side, we take the square root. And when we take the square root of the left hand side and the left hand side at the same time, we'll be left with x plus b on 2a's to be equal to square root of numerator on square root of denominator. That gives us positive or negative b squared minus 4ac, all that on 2a's. To have our x, we now just carry plus b on 2a's the right hand side, or we subtract b on 2a from both sides, and we'll be left with x to be equal to negative b on 2a's plus or minus the square root of b squared minus 4ac, all that on 2a's. Since the denominators are the same, we can just add the numerators, and that gives minus b plus or minus the square root of b squared minus 4ac, all that on 2a's as required. If you don't understand anything, you can watch the video again. Note, what we have in the root sign b squared minus 4ac is called the discriminant. It discriminates and tells us the nature of the roots. So delta is equal to b squared minus 4ac is called the discriminant. Now let's look at the nature of roots. If delta is equal to 0, that is b squared minus 4ac equals 0, we will have real and repeated roots, and we solve the equation b squared minus 4ac equals 0. If delta is greater than or equal to 0, we will have two roots which are real and distinct, not repeated like in the first case, and we solve the equation b squared minus 4ac to be greater than or equal to 0. Thirdly, if delta is strictly less than 0, then we are going to have imaginary roots, or roots which are not real, or call them complex roots, and we solve the equation b squared minus 4ac strictly less than 0 in case we have been asked to look for any parameter using this idea of the nature of roots. Thank you so much and stay tuned. It's been Math 24. Don't forget to subscribe, to leave your comment, and to click on the notifications. Bye bye.